All right, y'all. So we're going to finish up this last bit of notes for you. And then you have a worksheet on Test 6 Lesson 1 to work on, and then a Delta Math, which is in Delta Math, but I also printed hard copies for you to write on because you do all have the same questions in Delta Math for the assignment on Taylor and Maclaurin polynomials, okay? All right, so going with example number 7, okay? So we finished up with everything all the way through example number 6. So example number 7 says use a fourth Maclaurin polynomial to approximate the value of e to the 2.1 to 5 decimal places. Okay, so now for everything else that we've done so far, we've basically been given an x as we've been given the polynomial. So like if you look up at example number 5 or example number 6, on both of those you were given a like the function f of x. And then when we were approximating the value like in number 5, that was easy to do because we had the original function. Okay, we weren't given an original function here, but ultimately what we want is we want our x to be close to 0. Okay, so whenever I'm looking at this right here, okay, we want x to be close to 0. Okay, so if I was to make my exponent up here x plus 2, okay, because 0 plus 2 would give me 2, which is really close to 2.1. Okay, so we are going to create our function using x plus 2 as our power because we don't have a general function right now. We just have a specific one. Okay, and they want us to use a fourth Maclaurin. So we do know c equals 0 for Maclaurin. All right, so we're going to start with our f of x being e to the x plus 2. Okay, so if I do that, c equals 0, so we're going to say f of 0 would be e to the 0 plus 2 is 2. All right, then we're going to go and do the derivative. So f prime of x would stay the same. E to the x plus 2 times, that would just be times 1, which we don't have to write. So then f prime of 0, again, would be e squared. And we know, based on what we know about derivatives and so forth, that we're going to end up in the same situation for every derivative we have. So we know that every single time it's going to come out to be e squared. So if they want us to find the fourth Maclaurin polynomial, that's p sub 4 of x, okay, we know that our original value for 0 was e squared plus e squared times x plus, it's going to be e squared again. This time it's over 2 factorial times x squared plus e squared again over 3 factorial times x cubed plus e squared again over 4 factorial times x to the 4th. Okay, so that is my piece of 4 of x value. Okay, and then they want us to approximate the value of e to the 2.1 to 5 decimal places. Well, if we're using the function that we chose over here, which was e to the x plus 2, so we know basically that x plus 2 is going to equal 2.1, so we need our x to be 0.1. So we're going to do p of 4 of 0.1, and I will let y'all write all that in. I know you're probably not going to because I'm about to give you the answers, so I don't want to wait, okay? And you should end up getting 8.16616. Okay, double check that. You have time in class, so double check that. Make sure you get that answer whenever you type that in. Okay, so then down here at the bottom, all right, we have Taylor's theorem. All right, so if a function f is differentiable through order n plus 1 in an interval containing c, then for each x in the interval there exists a z between x and c such that. Okay, so if you pay attention, right here, f of c plus f prime of c x minus c plus f double prime of c over 2 factorial x minus c squared, all of this right here was the polynomial. And then this over here should look familiar as our remainder. Okay, there exists z between x and c such that the polynomial plus the remainder, where the absolute value of the remainder equals the actual minus the approximate. Okay, so that means the absolute value of f to the n plus 1 times z, or of z, sorry. So that's the derivative, okay, over n plus 1 factorial times the absolute value of x minus c to the n plus 1. Okay, ultimately this right here is representing our error. This is going to represent our max value. And then I do want you to pay attention to the n plus 1 on both of these, okay, representing our next term. And then C here, remember, is our center. Okay, so all of this is stuff we've actually kind of seen before. Well, it still is something we've seen before, okay? That's a numerical derivative, okay, of z over n plus 1 factorial times the absolute value of x minus c to the n plus 1. Okay, we've seen the remainder. We've seen this polynomial function. All right, so now let's apply it. Okay, so let x be a function that is continuous and differentiable for all real numbers, and let f of 3 equals 2, f prime of 3 equals 6, f double prime of 3 equal 1, and f triple prime of 3 equals 7. Write a third order Taylor polynomial for f of x about x equals 3. So right here, this is our c. We're writing a third order, so that's going to be p sub 3 of x. Okay, they gave us the original. F of 3 is 2 plus f prime of 3 is 6 times x minus c, which would be x minus 3, plus f double prime of 3 is 1 over, that would be 2 factorial, times x minus 3 squared, plus triple is 7 over 3 factorial times x minus 3 cubed. And there is your third order Taylor polynomial. That's it. Okay? Then they go on to say, if the fourth derivative of x is less than or equal to 5 for all x, find the Lagrange error bound for the polynomial on the interval 2.83. Okay, so remember, going back to that function, okay, right here. Okay, so looking at this right here. All right, we're going to say that our error has to be less than or equal to the absolute value of the max of the fourth derivative of x. Whoops, my absolute value bar shouldn't be there. Well, it should be on the top, not on the bottom, sorry. Okay, so just the absolute value of the top. Okay, over 4 factorial times the absolute value of x minus 3 to the 4th. Okay, so now we know the max of the fourth derivative of x would be 5. Gives us that right there. Over 4 factorial times our x is going to be 2.8 minus 3 to the 4th. Okay, and if we type all that in, let me double check it. It should in fact give you 1 over 3,000. Now I typed that in step by step for me, but you could always do that in one thing on your calculators, especially since you can see it. So it is going to be less than or equal to 1 3,000. All right, 2011 AP Calculus BC exam question FRQ 6D. Let f of x equal sine of x squared plus cosine x. The graph of y equals the fifth derivative of x is shown. Let p sub 4x be a fourth degree Taylor polynomial for f about x equals 0. Okay, so that's good. X equals 0. All right, using the information from the graph of the y equals the fifth derivative of x, show that the p sub 4 of 1/4 minus f sub 1 of 1/4 is less than 1 3,000. Okay, so remember our function itself is our actual, and then this is going to be our approximate. In this situation, this is our approximate minus our actual. Okay, so if we use that, it's going to be less than or equal to the absolute value of the max of the fifth derivative of x over 5 factorial times the absolute value of x minus 0 to the fifth. All right, so let's look over here at, we need to find the max of the fifth derivative. Okay, so we're going to look over here at 1/4. So if this is 1, 1, 2, 3, 4, so these are in increments of 1/4. So this is 1/4 here. And if I go up, it looks like it intersects about at 30. So that means I can plug that value in for the max of the fifth derivative. So 30 over 5 factorial times the absolute value of our x here is going to be 1/4 minus 0 is just 1/4 to the fifth. Okay, so if we work all this out, we are going to get 1 over 4,096, which we know is less than 1 over 3,000. And so when it says up here, it says show that. When you make this statement right here, that satisfies the show that requirement. Okay? So you found it to be 1 over 4,096, but it says show that that is less than 1 over 3,000. And so you did that with your calculations right there. And then, of course, here we go. This is 100% us when we hear Taylor. Okay? All right, so again, lesson 1, convergent divergent on our root and ratio series is going to be, our root and ratio test is going to be the worksheet, and then a delta math on Taylor and Maclaurin polynomials is your second assignment. And tomorrow we will do power series. Okay? All right, I will see you all tomorrow.